Yes, now welcome back, and we are still dealing with physical properties of alkanes. We are still on this table. Now let us come to physical states. These are alkanes, and these substances have simple molecular structures. They have intermolecular forces of attraction, but the first four alkanes, 1, 2, 3, 4. What do you see? They exist as gases at room temperature. Methane is a gas, ethane is a gas, propane is a gas, butane is a gas. Calm down. Pentane, hexane, heptane, octane, nonane, decane, all these are liquids. So why is that variation? That is something that as a chemist you must be able to explain. We learned that in Form 1. In Form 1 we learned that for something to exist as a solid or as a gas, then all that depends on one thing: the particles, the attraction between the particles. So we say that the gases, the particles of gases, for a gas, the particles are far apart. But do the particles choose to be far apart? It is not their choice. What makes the particles to be far apart are the intermolecular forces of attraction. Intermolecular forces of attraction. If the forces of attraction are weaker, then the intermolecular forces of attraction are weaker, then the particles will be far apart. They are free to move, just like we have seen in gases in Form 1. Gases have particles which are free to move and they are far apart. Reason, the intermolecular forces are very, very weak. That is what happens in methane, ethane, propane, and butane. Why? Because they have relatively smaller molecular masses. And because they have relatively smaller molecular masses, what happens to the intermolecular forces of attraction? We have seen that when the molecular masses are smaller, the strength of the van der Waals forces are also very weak. And because the attractions are the forces of attractions are very weak, then the particles are free to move. And therefore, these things occur as gases. That is one. Now, to summarize that, it has been summarized in this point that the first four straight chain alkanes, methane, ethane, propane, and butane, are gases because they have relatively smaller molecular masses with very weak van der Waals forces. Hence, their molecules are far away from each other and free to move. So they exist as gases. Let's go back to the table. Now, going back to the table, we have said the rest from number 5 up to the one with 10 carbon atoms exist as liquids. Why? Because they have large molecular size. Large molecular sizes, moderately large molecular size, moderately larger molecular sizes, which results into stronger what? Intermolecular forces of attraction. And because of that, the particle sizes or the particles are closer to each other. The particles are drawn closer because of this relatively stronger intermolecular forces of attraction. So, what happens? This thing will exist as liquid. It will have the property of a liquid. That one is summarized in this point number 7. So in point number 7 we are saying the next 6, that is pentane, hexane, heptane, octane, nonane, decane, are liquids. Why? Because they have moderately stronger intermolecular forces of attraction. Hence, their molecules are brought closer, causing them to exist as liquids. Causing them to exist as liquids. So, that is why they are liquids. Now, another thing that I want to talk about alkanes is solubility of alkanes. Solubility of alkanes. This one is very important. When we talk of solubility of alkanes, I want you to reflect back on what you learned in Form 2 under structure and bonding. These are molecular substances. Now, one thing about alkanes is that alkanes are nonpolar in nature. Nonpolar molecules are insoluble in water. Why? Because water is a polar solvent. A polar solvent will dissolve a polar substance. A nonpolar solvent will dissolve a nonpolar compound. So likes dissolve likes. That's what summary. Now the next, so alkanes are insoluble in water because they are non-polar if you are asked to talk about solubility. Coming back to the table, the last part is density. That's the last column that we are going to explain. The density, if you look at the density of alkanes, the density increases. There is no group here. Don't say density increases down the group. The density increases with increase in the number of carbon atoms. Why? Because of increase in the molecular masses and increase in the intermolecular forces of attraction. What the molecular forces of attraction does is that it pulls, when the intermolecular forces of attraction is stronger, it will pull the particles closer together. When the particles are pulled closer together, that substance will become more compact. Compact, the compactness of the structure. As you move from methane to heptane to decane, the particles are moving closer and closer. What happens? The structure is becoming more compact and more compact as you move down. That compactness of the structure of alkanes results into increase in the density of the alkanes. That one brings us to the end of this discussion. Thank you for listening. Let us meet next time.